Hello everybody, welcome to the 9.6 practice, which has some review from 9.5. This is going over the practice problems that you just took, so if there's any questions that you have, you can definitely flip to any part of this video to help out. So the first problem on your practice problems today asked you to find the limit of this function. And the first thing I asked you was, is this top heavy, bottom heavy, or even? Because the power on the bottom is much larger than the power on the top, this would be considered bottom heavy. And if it's considered bottom heavy, I would again like you to find two things. I'd like you to find the limit as x is approaching infinity, and I'd also like you to find the end behavior asymptote. And what that means is, do you have a horizontal asymptote or do you have a slant asymptote? And so from an earlier video, if you have something that's bottom heavy, that means that you have a horizontal asymptote, and if it's bottom heavy, that horizontal asymptote is y equals 0. Now, in the same light, if you're finding the limit as x is approaching infinity, this has very much a relationship with this asymptote that you found from the previous day. So when you're going to infinity, that means that you're looking at the ends of your graph and you're saying, what is the end behavior doing? Where is this graph going? So as you're going towards infinity, if you plug infinity into something squared, you get a really big number. But then if you plug infinity into something that's to the 8th power, you get an even larger number. And so if you take a large number and divide it by an absolutely huge number, that is going to approach 0. So the answer to the limit is 0, and the answer to the horizontal asymptote is also 0. So your answers will be the same, because if you think about what a limit is, and you think about what an asymptote is, if you look at the line y equals 0, picture your graph going down and slowly getting closer and closer to 0, but not quite touching it. That is what a limit is. It is getting close to an asymptote. It is getting close to a hole. So whatever answer you get here will be the same as the limit as you go to either infinity or negative infinity. The second example I had, I asked the same thing. I asked first if this is top heavy, bottom heavy, or even. So this time the power is x to the first and x to the first. So this time this is technically even heavy, or just even. And if it's even heavy, you also have a horizontal asymptote. And that horizontal asymptote this time is not y equals 0. If you have the same power top and bottom, you compare the coefficients in front of those powers. So the equation will be y equals 9/7. If you think about what the limit would be, is x is going to infinity, or is it getting closer and closer to a specific type of asymptote here? Think about plugging in a really big number like infinity. 9 times infinity over 7 times infinity. Even a bigger number. We're doing 9 times a huge number divided by 7 times a huge number. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. This number would cross out and you'd be left with the coefficients. So your limit as x is approaching infinity is 9/7, which is the same as your horizontal asymptote. Number 3, I asked you, what is the limit as you're approaching this function? Now, the first thing, if you're thinking bottom heavy, top heavy, or even, this time we have a top heavy function, which means I have a slant asymptote. So if you have a slant asymptote, my suggestion would be to find what the slant asymptote is, because that will also help you find the limit. So in order to find the slant asymptote, we have to do division. In this case, because we're dividing by something that's x squared, we have to do specifically long division. So I'm going to write out my problem, x squared plus 5x minus 2, divided into, luckily we have nothing we have to put as a placeholder, so I'm just going to go through the process here. If I take x cubed and divide it by x squared, we're left with x. Multiply the x back to everything. We would get x cubed plus 5x squared minus 2x. And then I'd have to remember to change my sign because I'm really subtracting. So we have a negative here, positive here. If I combine down, I would get negative 2 and negative 5 is negative 7x squared, and then plus 9x minus 8. And then I see if I can do this again. Can I divide x squared into negative 7x squared? Yes, I can. Negative 7 times. So I put a negative 7 up there, and then I would multiply that negative 7 back into everything. So I'd get negative 7x squared I would get minus 35x, and then I would get plus 14. Then I would have to change all of my signs because I'm subtracting. Positive, positive, negative. These cross out. You're left with 44x minus 22. So is x squared divisible into 44x? No, it's not. So when you're finding an asymptote, you don't care about the remainder anymore, and your answer is from what's left in the top. So your slant asymptote for this problem is y equals x minus 7. And as soon as you have your slant asymptote, then you can actually find your limit. You could also plug in a really big number in at the beginning of the problem, but I think it's really helpful sometimes once you have this answer to graph it and kind of see what happens. But you can think of it either way. So if I thought about it graphically, this is the line y equals mx plus b. So we'd start down 1, 2, 3, 4, 5, 6, 7. We would go up 1 over 1, up 1 over 1, up 1 over 1. So we'd have a line increasing from left to right. And we're asking what is the limit as x is approaching infinity, or as x is going to the right, what is y doing? Well, y is increasing as well. So your answer for the limit would be infinity. If you plugged in infinity or a really big number to the top and a really big number to the bottom, you might have guessed the answer was infinity, but it is important also to be able to find the slant asymptote, which is why I wanted to make sure to do this one. The next one, if we take a look at the problem, I don't know why my computer keeps doing that, how annoying. So this one, top heavy, bottom heavy, or even, I noticed that we have x squared on the top and x on the bottom. So this again is top heavy because we have a higher exponent on the top, which means again I have a slant asymptote. But something that's awesome about this problem versus the last one is that what you're dividing by is linear. So you can use synthetic division instead of long division. So you could put the 7 in the box. The reason it's positive 7 is because you set this equal to 0 in your head. You write down the lead coefficients from what's left over, bring down the 1, multiply, get a 7, combine, get a 2, multiply, get a 14. Hey, we have a remainder of 0. That's nice. So what is remaining here is the equation y equals x plus 2. So my slant asymptote is y equals x plus 2. Okay. Now, in terms of the limit, again, you could plug in a really big number top and bottom, and you could probably guess what the answer could be, but I'm going to think about it graphically again. If I have y equals x plus 2, I have a y-intercept of 2, and then I'm going up 1 over 1. So my line, my asymptote line, or my end behavior line, is increasing. So as I'm going towards infinity to the right, my graph is going up towards infinity. So this answer, again, is infinity. This one I put just because you need to pay attention to order here. As x is going to negative infinity, what's happening? Now, we haven't had any examples yet that went to negative infinity, but whenever you have a function that you're taking something divided by something else, you still need to ask yourself if it's top heavy, bottom heavy, or even. So this time, just be careful. The highest power on the top is negative 6x to the 11th, and then the bottom is 8x to the 11th. So this time, it's even heavy because we have the same power top and bottom. And if it's even, we have a horizontal asymptote here. Let me write that correctly. So we have horizontal. And that equation will be y equals, well, when you have the same power top and bottom, you compare the coefficients in a ratio. Make sure to reduce that ratio to be negative 3/4. So your equation is y equals negative 3/4. And that means if your asymptote is negative 3/4, which would be down here, that means that your graph is slowly approaching negative 3/4, which means this limit, the answer is also negative 3/4. Now I love these problems. Notice that all the problems to come and the problems on your practice problems, these are not originally fractions. And so when you originally do not have fractions, you can't ask yourself if it's top heavy, bottom heavy, or neither. So instead, if you don't have, so I'm going to write a note, it's not top heavy, not bottom heavy, and not even. So what you need to do is draw a picture. like we did for the slant asymptotes. Think about what this looks like. If you have a function where the highest power is squared, that is a parabola facing upwards because the lead coefficient is positive. So let's think about what's happening. As x is going towards infinity, what is y doing? Well, it's going up, so my limit is infinity. This one over here is the same exact function, except you're thinking about negative infinity this time. Your function is still an upward-facing parabola, but this time, as x is going towards negative infinity, you got to think about what y is doing. Y is also going upwards, so the answer to both of these is positive infinity. The next one on the practice problems gave you these functions, and notice that the highest power in both of them is x to the 7th, so you base everything about what it looks like based on that. If you have an odd power that's the highest degree, this is going to look more like a snake, not a parabola. You might remember that from earlier in the semester. So if you have a positive lead coefficient, because that's the highest power, and it is odd or looks like a snake, your snake is going to be rising from left to right. And so let's ask ourselves what this is saying. As x is going to positive infinity, what is y doing? Y is going up forever. So this answer would be infinity. However, for this example, as x is going to negative infinity, y is going down this time. So your answer is negative infinity. So what you're really doing when you're finding a limit is you're asking, where is the graph going? What is the end behavior, aka what are the asymptotes doing? In this case, we don't have asymptotes, so we have to draw the picture. Here are two more. This time, the lead coefficient is negative and the highest degree is 4, which means this is going to be more parabola-like. It's more parabola-like and it's going to be facing downwards. So your graph is going to look something like this. I mean, it's just a sketch just to kind of get an idea. And now let's think about what we have. As x is going to positive infinity, the graph or the y values are going down. So we have negative infinity as our limit answer here. As x is going to negative infinity or towards the left, the y's are also going down, which means this answer is also negative infinity. Last but not least, this function. The highest power is to the 5th. The lead coefficient is negative, which means this is more like a snake, and it's going to be facing the opposite direction. So usually a snake is rising from left to right. So this type, the snake is going to be falling from left to right because the lead coefficient being negative. So now, as x is going to positive infinity, the graph is decreasing. So your limit would be negative infinity. Here, as x is going to negative infinity to the left, the graph is rising. So your answer is positive infinity. All right, guys, I hope this video was helpful. If there's any other questions you have before taking your exit slip, feel free to stop by any of the Google Meets, 2nd, 4th, or 6th period. Thank you.